Hello, my name is Bobby Schultz. I am an undergraduate at the University of Minnesota Twin Cities, studying electrical engineering and computer science, and I'm also a former student at the Prairie School. Now, previously, we've talked about transistors, and particularly how you can drive a motor being controlled by a transistor in a single direction. Now, today we want to talk about how you drive a motor not in a single direction, but in two directions, meaning forward and backward. So, in order to do that, you need to take a motor, and what you want to actually do is route the current through it in opposite directions. So you allow current to flow one way through it from positive to negative, and then you allow it to flow the opposite way, and that will cause the motor to drive in the opposite direction. Now, as you can imagine, being able to control a motor going both ways is a very useful thing. Driving, say, a small car or something like that, it's very important to be able to go both ways. Of course, we can't do this using a single transistor. That only allows us to drive it in one direction forward. That means that we'll need what's known as a transistor network. Now, this particular transistor network is what's known as an HBridge. Now, what an HBridge does, it's a series of transistors, 4 transistors usually, that will allow current to be routed, depending on several pins being high or low, through the motor in either direction. Now, we're going to talk about how you build a HBridge and then how you actually apply it. So, next up, we're going to talk a little bit about the circuit of a HBridge and a little bit of the math behind and the different circumstances of how you can set up a HBridge. So let's talk about that next. Alright, so we talked a little bit about what an HBridge does. Now let's take a moment and talk about how it actually does this. Now right here we have, this is our entire circuit for our HBridge. Up here we have these are going to be two PNP type transistors, and down here we have two NPN type transistors. And then in the middle here we have our motor or our load, what have you. Now I've modeled this using BJT transistors just because we've talked about those before and we know how those work. Over here, as you can see, we've tied together the bases of these two transistors into what we're calling A. And over here we've tied together the base of these two transistors into what we call B. Then down here we have the emitters of both of our NPNs tied to ground, or our low battery voltage is going to be minus VB if we're using a battery. And then up here we have our input voltage, which is going to be our positive battery voltage. This is going to be our plus VB, and that's important as well. Now let's take a look at this. So the 4 different cases that we can have, if you're thinking in on-off states, are this. So we've got our A and we have our B, and those are going to be our lines that we're going to switch. Now we can either have A and B both be off, both be in a low state. We can have A be in a high state and B be in a low state. Or we can have A be in a low state, B be in a high state, and finally we can have both of them high. Now these are the 4 different combinations we can have. Now if we take a second and examine this circuit, we'll notice something, that if one of these lines, so either A or B, is brought low, that will mean that the respective PNP transistor is going to be on. It's going to be activated. It's going to allow current to flow through it. Now, if said channel is brought high, that will bring this NPN transistor active and allow current to flow through it. Now, this is important, how this is set up, that we haven't done this in some different orientation, because there is no orientation that we can set A and B such that our current will flow like this through our transistors. And that's good, because that would be very bad, of course, if we simply short VB down to minus VB through these transistors. They would likely be destroyed. So it's important that we have a sort of a foolproof setup in that sense, that we can't cause that error to occur. So now let's look at the combinations we do care about. Now, if we set A to be low and B to be low, as you can see, that will mean that both of our PNP transistors will be on, but neither one of our NPNs will. And so, of course, no current will flow. And then same case with if we have a 1-1 state. Both of our NPNs will be on, but neither of our PNPs will be on. And so, once again, no current will flow through the motor. That means that of these states, only 2 will actually have the motor running. Both of these states will simply have the motor in an idle mode. These are the 2 states that we care about. And this is the whole beauty of the HBridge. So now, let's say we have it in this first state here. So we're going to bring A high, which means it's going to flow through this transistor. So this transistor will be on, and then, or I apologize, this transistor will be on, and then B will be brought low, meaning that this transistor will be on. This then means that current will flow through this PNP transistor, through our motor, and out through this transistor. Now I know that can be a little hard to picture, so it should look something like this. That's how our current is going to flow through in that first combination. Now, let's say that we combine it in an opposite format. So now we're going to use this other combination. We're going to have A be low and B be high. That will turn this transistor on and this transistor on, which will then allow current to flow in this formation. Now, as you notice, the actual way that the direction of the current flow, that in this case is going to be opposite what it was in the previous example. In the previous example, our current flow is actually like that. That means that just by switching these two lines, we've actually reversed the current flowing through our motor. That means our motor will run in the opposite direction, which was our goal the entire time. So as you can see, this HBridge circuit works to flip the polarity of the motor by changing the way that the current flows through it. Now this can be used to actually drive a motor. Now next, let's take a look and actually build this circuit and actually show how a motor runs with it. Alright, so now that we've talked about how to construct a HBridge, now let's actually see one in action. So here I've built the exact HBridge that we were discussing before, just using these 4 transistors, and the power supply, and then here we just have a little toy motor that's going to run. And the only difference that I've made is I've actually added an ammeter in line with our motor so that we can see the polarity of the current, so that we can actually see that the current is indeed flipping. Alright, so let's get this started. Now right here, these two lines, this blue and this yellow, are going to be our A and B line, blue being A and orange being B. Those are going to be our control lines. So right now they're both driven high to the high side of our power supply, and as you can see the motor is not running and no current is flowing. So now if we take these and drive them both low, we should also see nothing happen. And just like we predicted, there is no current and the motor is not running. However, now if we take one and switch it high and the other remaining low, then we should see a change. Now here if we take B and switch it high while leaving A low, the motor runs as we said it would. And as you can see, we have a positive polarity of the current. We have 0.14 amps in the positive direction according to how the ammeter is set up. Now let's reverse this. Let's place B low and drive A high. Now as you can see, we have an equivalent magnitude current, but it's in the negative direction. We've actually flipped the polarity of that current. And of course the motor is running in the opposite direction. But if you can't tell, you can see that the polarity of the current has indeed flipped, which was our goal with this HBridge. So now let's shut this off, driving it both low again, and it's off. So with this HBridge, you can drive a motor in opposite directions, and you can also, by driving both high or low, actually turn the motor off. Now you could do this with, say, a microcontroller. Have an Arduino control those two lines, and that would allow you to switch the different directions of these and control your motor. Now, an HBridge like this is especially important for any kind of robotics where you're going to be dealing with a motor, or really any application where you're dealing with, a traditional brush motor like this, because it will allow a great deal of control, and it will allow you to, of course, reverse your direction of motion, which is important in most any role of a motor, unless it's very simplistic. So I hope that this has helped with your understanding of how an HBridge works, what an HBridge does, and actually applying an HBridge to a project that you're working on. So I hope that's been helpful.